Good afternoon, ladies and gentlemen, and welcome to the session. I've got a bit of a problem, actually. I can't quite work it out. For some reason, I've got the two Sleepy Zone sessions this week. Now, is it me, or is it Active Directory? It's Active Directory. Well, maybe it's me. Oh, it's me and the Active Directory. All right. You're a politician, sir. Anyway, welcome to the session. How many of you came to my Active Directory 2012 session? Okay, so that was talking about WAD. I'm going to mention a little bit about WAD and WAD in Azure. If that makes no sense at all, you'll find out in a second what I'm meaning. So just to give you a little bit of background, I work out of the UK as a consultant, do a lot of work globally, tend to work with sort of fairly large organizations, governments, sort of major banks and major energy suppliers and things. Speciality for years was Active Directory. I'm very much involved in the federation identity space, and I just love networking. So on Sunday, I did a very deep dive on direct access with all the great stuff of IPv6 and all those exciting things. But today, we're going to talk about running Active Directory in Windows Azure. But how many of you read the outline on the website? So a few of you did. Not even half, but some of you did. What I want to do, first of all, is actually start off by contrasting it with the Windows Azure Active Directory. And then we'll look at why you might run your own Active Directory in Azure. So the idea, first of all, is to set the scene with looking at Windows Active Directory versus Windows Azure Active Directory, and then why you might put your own AD up there, the design considerations and options, and then I want to take you through a step-by-step process of how we do that. Now, how many of you are familiar with putting a virtual machine into Windows Azure at the moment? Okay, so probably less than 25%. I'm not going to go into all the details of Azure. What I will do, though, is highlight the things we need to consider when deploying Active Directory up there. Okay, and you'll get a feel for how things are done, but I can't teach you all about Azure and putting Active Directory into Azure. So Azure, first of all, just to set the scene, it's a platform on which we can have compute engines, we have storage engines, SQL database, and there's various compute roles, web roles, worker roles, websites, and virtual machines. The websites and virtual machines, as sort of infrastructure as a service style virtual machines, came out in 2012. And that's where we're going to put our AD, if we put our AD into Azure. There's blobs, tables, and queues in terms of storage. Blobs are just binary large objects, and that's where we put our VHDs, our virtual hard disks. That's where we put our data disks when we're running up in Azure. And then there's a whole bunch of Azure services, one of those services being Windows Azure Active Directory. So, Active Directory, and if you saw my session 2 days ago, you will have seen this slide. So apologies for a repeat for those people. We've got Windows Active Directory that we all know and love, and this is the WAD aspect, W-A-D. And in terms of, there's a whole raft of services that go with it, and in particular, the directory services, where we've got Kerberos authentication and we've got NTLM authentication. And of course, we've got an identity store where we can store our users. And then we've got Windows Azure Active Directory. And the real difference is, with your Active Directory, you look after it end-to-end. You look after the infrastructure, you look after the data that goes into that infrastructure, you manage all the services. With the Windows Azure Active Directory, Microsoft hosts it for you. So all you do is you manage your data in it. Okay? Is it the same as Windows Active Directory? Not at all. It's a very, very large, highly resilient, highly scalable identity store. And you manage your data, and then you choose the services you want to use in terms of authentication services. So it's all sort of about federated authentication. So WS Federation, SAML, OAuth, etc. There's going to be more to come on that space as well. And then there's the access control service, which I'll come to in a second. So in terms of actually looking in a bit more detail, what it is this, it's really the latest release of the Office 365 directory, which has been around for a long time. It's proven itself. And if you, how many of you actually came to the keynote? Okay, so question, how many transactions per second was the Office 365 directory managing? 9,000, I heard. 9,000 per second. Well done. Just give you, there's a statistic there over a 90-day period, 65 billion authentication requests. So it's capable of scaling and being highly resilient. So what do we use it for? Well, we've got a management portal where we can add our users. We've got a set of REST APIs where we can add and manage our users. We've got a graph API where we can actually get a hierarchy structure or hierarchical structure of our users. So if we want that information, we can find out who the manager's manager is, and so on. We can go all the way up through the hierarchical tree. You can synchronize it with your own AD if you want to. And then you can authenticate against anything that supports claims or supports federated authentication. So I could have my Azure subscriptions federated and authenticated with the Windows Azure Active Directory. Office 365, obviously, but your applications. And where are your applications? They could be on-premise. They could be in the cloud. Partners, where's the partner application? On the partner's premises or in the cloud somewhere. And it really doesn't matter where the application is. If we're using Windows Active Directory, we're very tightly integrated with, domain joined. Where's that app? Well, if we push it outside of our nice, secure boundary, we've got problems. And we're very much stuck with Kerberos and NTLM authentication. When you create yourself an instance of the Windows Azure Active Directory, you get John Smith at yourdomain.onmicrosoft.com. And then you can add your own domains. So you can have John Smith at yourdomain.com. So you can add a number of domains into the directory. So if we just quickly look at the authentication flow, we've got a user over on the left-hand side, hits a claims-aware application. It's browser-based. We can also do web services-based as well. We hit the application. It says you're not authenticated. Right? It's browser-based, so it's all done through redirects, HTTPS puts, gets, and so on. It then redirects us up to the Windows Azure Active Directory. At that point, we can authenticate. We get a security token, and we get a security token which that claims-aware application can consume. We then present that back to the application. The application then can use the APIs to actually retrieve whatever information it needs about that user. So we've identified the user, and then we can go back and we can get the user's manager, the email address, whatever you want to allow to come out of the directory. And then finally, we return some cookies, and we're in. So this application, where is it? It could be absolutely anywhere, and that is the real benefit of using federation. You can also use your own Active Directory for authentication, and to do that, you need Active Directory Federation services. So this time, you browse the app, you'll bounce back, not authenticated, off to the Windows Azure Active Directory, and it does what's called a home realm discovery. Basically, you start to type your name in, and if that username is recognized by Windows Active Directory as one of the users that directory authenticates, you put your password in, and you authenticate. Otherwise, what will happen is it immediately redirects you off to the ADFS server that you have the federated relationship with. At that point, you authenticate against your own AD, return the token, present it back to the Windows Active Directory AD, sorry, the Windows Azure Active Directory, and then process the token, it returns it, and finally we pass it back to the claims-aware app. I refer to this as sort of federation dance, and it looks very tortuous. But as soon as you've got the cookies, you don't need to bounce around all the time. So every time you go back, you've got session cookies. And you can then retrieve the user information as much as necessary. To be able to do that, we do directory synchronization. So we're synchronizing our users from our AD into the Windows Azure Active Directory, and then we return the cookies and the page. Last bit of the equation is the access control service. At the moment, we have the identity store, the authentication mechanisms, and we have the access control service. There will be more in the future. There will be future services. But the idea of the ACS is that it's a broker service, so we can federate against different identity stores. So Live ID, Google, Yahoo, Facebook, your own AD, your partner's AD, and so on. And also, of course, Windows Azure AD. And the way it works is the user hits the application. The application will then redirect the user up to ACS. You then choose what you want to authenticate with. And at that point, you bounce off to the appropriate identity provider. You get a token from that, which is represented back to the access control service, which processes the token, passes it back, it gets passed to the application, and then you're done. And I just want to very, very briefly just quickly show you a SharePoint server, which I deployed into, well, it's actually sitting in Azure, but it could be sitting absolutely anywhere. And for that, I need to actually do a bit of in-private browsing. So it's XTS Cloud, it's XTS cloudapp.net. And there it is. Do you want to go Windows Live ID? Why not? So I can now authenticate against that with a Live ID. I could have chosen to use a Google ID, or in fact, I can use a Windows Azure Active Directory ID. And I've got this character, John, and we'll just log him in. OK, so that is SharePoint federated with ACS and the Windows Azure Active Directory. And why I particularly wanted to show you this and contrast with what we're really going to be talking about, which is putting your AD into the Active Directory, you need to think about why we're putting our AD up there. Is it about authentication? Because if it is, maybe you should be thinking about turning your apps into claims-aware applications. So SharePoint here has just been configured as a claims-aware application. And it is allowed to take these sort of, it's actually a pass by WS Federation. So it can take these tokens and actually do authentication based on the tokens that it gets. OK, so let's go back to the slides and ask ourselves the question is, why might we want to put an AD into Windows Azure? Some applications require it. OK, so if you want to run an app in Azure that requires it to be domain joined, right, or requires the server to be domain joined, then you're going to need an AD. You may decide that you want to use group policy to manage all your Windows Azure virtual machines. And that's not a bad way to go. You could do group policy. You could do Windows Update. Because remember, it's a virtual machine. It's running on top of a hypervisor. Microsoft will look after that, the hypervisor. The rest is your responsibility. So you can deploy, whatever you want to deploy up there, let's say Server 2012, and then you look after it, you patch it, you do the security on it and all the rest of it. And group policy is not a bad way to go, and also using the update services as well. You may decide that you want to use Server 2012 as the overall management console for all of your VMs, and you get very good management capability. And therefore, to do that, you would want to have an AD because they need to be domain joined to achieve that. So 2 options. You can go for a hybrid deployment, or you can go for a cloud-only deployment. If you go for a hybrid deployment, then you're probably doing it, and by hybrid, I mean that you have your AD, your corporate AD up there in some form, and I'll talk about the different forms you can have, and then you are connected to your on-premises AD. And that's the concept behind a hybrid. And it might be that you need your applications up in the cloud to gain access to resources down on-premises using Windows Identity. So that could be a reason for doing that we do. But think about federation, all right? I just want to federation is definitely the way that people are moving now. It's sort of starting slowly, but it's gathering a lot of momentum. And the advantage is, of course, today that application is sitting on-premise, or it's sitting in Azure, or it's sitting somewhere else, or it's sitting somewhere else. And you can move it around and still have your authentication. Cloud only, you're isolated from the corporate network, and it could be that you just need an app that's domain join, or the VM's domain join. You want your group policy. You want your update services. You want your server management. So in terms of design considerations, the DCs will be running on virtual machines, and we need to take that into account. The DIT and sysvol must be on a non-cached drive. The default drive for a virtual machine is cached. So don't just fire up a VM and say, oh, this is my DC, and where's sysvol go? Oh, it's on the C drive, in the Windows NTDS directory. If you do that, and the thing goes through what's called service healing, so the VM crashes for some reason, and immediately the Azure storage disks are reattached to a new VM, you would have lost any information in the cache. So the DIT sysvol has got to be on a non-cache drive. So as soon as a write takes place, it is actually committed onto your Azure storage. We need to take into account IP addressing and name resolution, and I'll come back on both of those. Well, I'll come back on all of this, actually, but in particular, I'm not going to mention any of that, any more of that right now. Should the DC be a GC? Should it be an RODC? Separate forest with truss, geo-distributed DCs, and optimizing for network traffic. So all of those things you have to take into account. First thing is it is running on a VHD. It's running from a VHD on a virtual machine. And what you've got to be very careful about, traditionally, could you restore from snapshot? Absolutely not, because you cause real problems to your Active Directory. Now, the Azure platform is running on Server 2012, right? So it has the capability of using what's referred to as the VM generation ID. And the VM generation ID is an identifier that is exposed through the hypervisor to the virtual machine. And what happens is when you do a DC promo, what will happen is the domain controller picks up this GUID or this ID, right? And then it puts it into the Active Directory. And it's actually in this thing, it's on there somewhere, MSDS generation ID. So it's now in the Active Directory, in the MS generation ID, and we have it in the hypervisor, right? And constantly, the two are being checked. All right? If there's a discrepancy between the two, what the Active Directory says, whoops, something's happened. I must have gone back in time. All right? Because that was normally happens. If you restore from a snapshot, you actually go back in time. And if it detects that change between the two IDs, what it will do is it will go into an AD restore. So when it goes into an AD restore, it changes its database identifier, and it is seen as a new replication source. It discards the RID pool, and it does a non-authoritative restore for sysvol. All right? So that's what happens. So it is effectively virtualization safe. However, there's a few caveats that you need to take into account when running on the Azure platform. You may have heard the announcement this week that you now have this stop-start operation where you can have a development environment, all right? Normally, if you just sort of stopped your virtual machines, went into the virtual machine and stopped it, and you weren't using it, you'd still be charged because effectively there's a virtual machine instance that's sitting there, all right? Now what happens is when you actually stop it in this mode, it's the VM sort of is hydrated, and then it's dehydrated again when you start it. So effectively, the instance disappears. Now, the problem is that when it gets rehydrated and it starts up again, the generation ID changes. So there is actually a potential, if you are running an environment where you've got multiple DCs, when they start up again, right, they will say, oh, generation ID has changed. Therefore, I'll do effectively an AD restore. No problem there at all. Replication will work perfectly. But sysvol does a non-authoritative restore. And sysvol does a non-authoritative restore on the next machine. And now we're in a situation where two non-authoritative sysvols, you've broken sysvol replication. Now, this was something interestingly enough, I pointed out to the Azure team this week, and they're now working on a possible solution. All right, but you only have to worry about it for a dev environment where you've effectively stopped, disengaged the virtual machine, and then brought them up again. Okay. We've also got service healing and also host servicing. Service healing is where a VM crashes, and Microsoft, effectively what they do is they start up a new VM and attach your hard drives, right? And at that point, what happens is the generation ID GUID will change. But in terms of service healing and also with host servicing, what we need to do is make sure that our DCs are distributed across what's called fault domains and update domains. There's this concept, a fault domain is a single rack, right? And you've got a single switch at the top, so potentially you could lose the rack or the part of the rack, right? So if you say, I want my DCs in an availability set, what Microsoft will do is it will put one DC on one rack, the next DC on another rack, all right? And the moment there's three fault domains that they'll distribute you across, and you put another DC on another rack. So if one goes down, then the other two are up there. So this goes down, it gets its VM or its VHD reattached to another virtual machine. It will start up, all right? It will go, oh, look, my generation ID has changed. What I better do is, pretend I'll do an AD restore, make my sysvol non-authoritative, but sitting right next to it in another rack somewhere, you've got an authoritative AD. So it all comes up, and that's good. But it does rely on you putting your domain controllers in an availability set. So do remember that, and I'll show you how we do that shortly. In a hybrid environment where you've got on-premise DCs, in theory, if all your VMs in the cloud came up and said, oh, we're non-authoritative, you'd have an authoritative resource sitting on premises. So it doesn't have to replicate. All it needs to do is actually exchange a little bit of metadata to make sure that sysvol is consistent with another sysvol. And if there are any changes, it just swaps those changes across, or not swaps them, but brings them across. So do remember, what's the key thing you've got to remember? Yeah, you put them in the same availability set, which then distributes them across the fault domains. And the update domains are done for, so if Microsoft has to service the actual VM itself, what it will do is effectively brings in a new VM which has already been serviced and reattaches your disks. So at that point, it is like, it's almost exactly the same process as something crashing completely. Question? No. So this is what the stopping is. No billing, because what would happen normally is prior to the announcement this week, what would happen is when you actually went into the operating system and you shut down your virtual machine and it's sitting there not running, what you do is you'd be charged. Right? Now what you can do is you can effectively stop it, all right, which effectively kills the virtual machine instance, but you can then start it, which creates a new instance automatically and brings your VHD into play. So, no, it's purely there for a dev environment. So the idea is you create your dev environment, you stop all the machines, and it stops the billing on them, all right? And then when you're ready to try that dev environment out again, you start them all, and at that point, the generation ID good changes. If you actually just shut a virtual machine down, and it's sitting there, remember you're being charged for it, all right, but the VM generation ID does not change. Does that clarify it for you? Yeah, good. Okay, we've covered that slide. So IP addressing and name resolution. Windows Azure DNS will not support the records needed for AD, so you need to bring your own DNS. Well, if you're bringing AD in, you'll probably be using the Active Directory DNS. IPs are dynamically assigned. You never, ever change them. And if you say, oh, hang on a minute, it would make sense if I change this DNS on my virtual machine. So you actually change the address of a DNS server. If you do that, and it goes through service healing, it goes through an update, all right, that will be lost. All right, so never, ever change the IP address. There's nothing to stop you doing it, but never, ever change the IP address on a virtual machine or any of the other sort of DNS addresses or anything else. We have to manage it a different way, and I will come back on that. Should a DC be a GC? And in a single domain or cloud-only environment, it's an absolute resounding yes. It's it's single domain. It makes absolutely no difference whether it's just a DC or a DC and a GC, because there's no replication traffic involved at all. In a hybrid multi-domain environment, the answer is probably yes. All right? But again, it depends on why you have put part of your Active Directory into the cloud. And the reason being, probably you want applications up in the cloud to be able to authenticate against on-premise servers, all right, and to be able to do that. But also, you may have users that need to authenticate against applications that are in the cloud itself. And one of the reasons for putting your AD up there is so that you have minimal authentication delays. Because some applications are very, very picky that if you come in and you try and authenticate against them, and they say, oh, yeah, hang on a minute, I'll just go across and we'll authenticate against on-premise, and then you'll find the application will fail. And so, the answer is probably yes, because if you don't, and it's a multi-domain environment, the GCs will be needed for authentication. So what will happen is, up here, you've got DCs but no GCs, so there will have to be traffic across down to on-premises. So if you lose this link and you want people to come in and authenticate using your identities, your Windows identities, it's going to fail. Possible solution is to use universal group membership caching. That would actually get around that particular problem. Should the DCs be an RODC? And what we need to think about is why did RODCs exist, or why do they exist? And they exist really, and they're designed primarily for insecure locations. All right? Think about that one. You put your DC up into the Azure cloud. All right? Are you trusting the Azure cloud? Do you trust the Microsoft data center security? If you don't, you should be questioning yourself about your whole plan on moving to the cloud. All right? So you can almost guarantee that for the majority of companies, the data center security is going to be better than your on-premise security. That's for most organizations. But so really saying, oh, have RODCs up there, all right, because of security concerns, well, RODCs can actually cause more problems than they're worth in terms of RODCs actually have problems with application compatibility, because an application writes to an RODC, but it actually gets referred down to a writable DC, and then it reads back from the RODC to see if the write happened, and you go into a vicious loop because it hasn't happened, because it's down, the write was actually down here, and you're reading up here. And there's all sorts of issues with RODCs. So RODCs basically are not recommended. Right? Yes, you can control with an RODC which attributes get replicated up into that location. But remember, why do we want to control those attributes that are replicated up there? It's to a DC that's sitting in a physically insecure branch office where people can get at it. In Azure, it's a highly secure environment. So you're not going to have people being able to sort of log into your DC and pull anything off it. Right? And, you know, if it's a security concern, then just reevaluate the whole thing. Should you be putting things up in the cloud? Separate forests with trust, the problem with those, we can create another forest up in the Azure cloud, and then we can have a trust with on-premise. But what have we got there if we do that is that we've got the pros. There's no AD replication across the VPN, so we have a on-prem to cloud VPN, so no replication happening there. In terms of security, you have a security boundary around the cloud, and you have a security boundary around your own AD, so around the cloud AD and around your own AD. But who can actually get up there and actually cause problems? Right? It's sitting in this secure data center. Selective authentication could be used to individual computers, so you can actually have selective authentication across the trust to individual computers on-prem. That would be another pro, if you like. Cons, increased authentication traffic across the VPN, log-on latency, potentially. So, you know, if you put a DC up there to solve the log-on latency problem, by doing this method, you've still got the log-on latency problem. And then you've got increased outbound traffic. So there's going to be outbound traffic from the cloud, and it's the outbound traffic you charge for. All right? And if the link goes down, your authentication fails. All right? So again, you have to consider, I mean, the first key question is asking, why am I putting my AD in the cloud? And should I be putting my AD in the cloud? Or could I do it, you know, because someone says, oh, it'd be great to use group policy and everything else. Fine, have a cloud-only AD. All right? The only real reason you want to put your AD in the cloud is because you want to come down from the cloud and authenticate against resources down on premises, or you want users to access things in the cloud using your Windows identity. All right? And if you do it across a trust and the link goes down, well, I think the technical term is you're stuffed. All right? So, you know, you need to think very hard. You know, sit down, ask yourself, why do we want an AD in the Azure cloud? If you decide that you want to geo-distribute, all right, your AD across different data centers, then what you're going to have is you'll have a virtual network in one data center, a virtual network in another data center, and you will have to replicate through your own on-premise. You can't today go data center to data center replication, because what you do is you establish a gateway between a virtual network in one data center and your on-premises VPN device. Right? So you will have to come through. Right? That may change. There's an awful lot. Makes Azure so exciting, because every day you open the portal and you do something slightly differently. The other thing to consider is absolutely optimize your traffic, okay? So make sure you set up your AD sites and your subnet definitions properly. Remember, AD sites you create to control replication of AD traffic, and then the subnet definitions you create so that the clients have site affinity. All right, so you know, in terms of when a client comes to log on, right, what's going to be taken account of is its IP address. And if it logs on to an AD and the AD looks at the IP address and says, oh, look, you're not coming to the right site, it will boot the client off to the correct site, and then the client will go over there. So think very carefully about your site definition, and in particularly your actual subnet definitions. And make sure your site link costs are appropriately set, because what you don't want suddenly is the cloud shadowing an on-premise site. Right? So if you have a failure down on-premises, make sure it goes somewhere else on-premises rather than up to the cloud. And do not use notify replication between on-premises and the cloud. All right? Make sure it's a scheduled replication, because I know an awful lot of companies now actually do notification across site links, because site links are just, you know, such high bandwidth these days. And why do you need sites? Why not just put everything in one site where you have sites, so you have site affinity, so your clients will actually go to a particular site. So we create the sites for the client affinity rather than for controlling the replication traffic. So it's a very common scenario now. Why not use it? Because you don't necessarily, in terms of notify, you don't know, of course you're going across the internet, you don't know necessarily your site link bandwidth that you've got. You're coming into the Microsoft data center, you're relying on their pipe size. It's not a controlled, all right? You don't absolutely know the controlled bandwidth across between you and up there. It's not a dedicated VPN, all right? It's a VPN, it's not a dedicated network link, is what I should have said. Okay? Okay, step by step. Number one, we create an Azure virtual network for the VMs, and there we define an affinity group. Now, what's an affinity group? You can decide to deploy in a region, all right? So let's say we chose to deploy, I don't know, Western Europe. That's where we're going to deploy. Okay, that's where our main business is. So we deploy in Western Europe. But how many data centers does Microsoft have in Western Europe? You don't know. And if you did know, which data center would your deployment be in? You don't know. All right? But what you can do is create an affinity group and say, by putting things into an affinity group, you're basically saying that I want these guys close together. So if we're creating a virtual network, it makes absolute sense that this virtual network is all together in one data center. And then when we create additional VMs and we attach them there, they will all be together. And we can, by having that affinity group, we can make sure our storage is in the same location as well. All right? So if I create a Western Europe affinity group, I can't say which data center it will be in, but I can guarantee that my things will be close together. All right? So the next thing is we created storage to hold the OS and the data VHDs. And let's just actually, I'm not going to go into the great details of storage, but let's actually just have a quick look at storage on here. And it's not going to play. So in the Azure cloud, you actually create a storage account. And I've got one here, which is XDS 101. It happens to be in Western Europe. And if I look at the containers it's got in there, it's actually got in here, this is where my VHDs are stored. Come on. What? Interesting. This is the nice part. This is the circle. This is known the Azure circle. Oh, there we go. All right, so I've got VHDs, and when we create a storage account, what you'll see is, in fact, let's go to the dashboard on here. What you'll see is you've got a blob storage, table storage, and queue storage. Tables and queues are used by web roles and worker roles for communicating. Blob storage is where we store our binary large objects. There's an access key associated with the storage, which I'm not going to click on and show you because I don't want you getting my access key, and it'll be recorded. So there's an access key, which means I can actually connect to this storage from anywhere I like if I've got the access key. So this is a thing called Azure Storage Explorer. And I can go and connect to XTS 101. And what we can see is all of the VHDs that are sitting currently in Western Europe. Right? And I can download and upload so I can actually move them up and down. Now, I've got a couple of DCs up here. I've got DC1, DC2, and I've also got DC1 and DC2 sitting down there. Notice these guys are 10 gig, and these guys are 127 gig. There's the operating system. I allocated a 10 gig drive for my DIT and my sysvol. Right? If I go back into Azure itself and look at my virtual machines, I can look at disk management here, and we can see that attached to DC1, I have a read-write, and it's a host cache for read and write, and then I have another disk attached, and the host caching is none. And that's really important that when you attach a disk, you make sure that this is the disk to put your DIT on, a sysvol, that it is not cached. All right? So when you do that and attach it, absolutely remember to do that. So in terms of the storage itself, as I say, you create a storage account, you say where you want your storage account to be, and here we'd have an affinity group. All right? So we create an affinity group if we were creating the storage account first, and we'd use that affinity group. So Western Europe affinity group, somewhere in a data center in Western Europe. Now, when we create a network and we attach it to that affinity group, then that will also be in the same data center as my storage will be. Okay, let's just go back to the slides for a moment. And so that's the storage account. And the next thing is we deploy the VMs and the OS. We attach our data disks. And the VMs, remember, should be in the same availability set. And I'll show you how to do that in a second because it's not absolutely obvious. We install ADDS, however you want to do it. Well, you know, if it's just a cloud only, then we'll simply do the newer version of DC Promo. So we'll install the roles. And then we deploy other VMs and join them to the AD. The whole thing can be automated with PowerShell. So we can just have a little PowerShell script that just goes ahead, runs, and creates machines. At the same time as creating the machines, it creates the data disks, attaches the data disks, and we're all ready to go. So what we need to start to do this deployment is we're going to need a virtual network. And this is referred to as the Windows Azure Virtual Network, or VNet. And it's created using private address ranges. So you choose a private address range, you create subnets on it, and the VMs and services can connect to other VMs and other services on that particular virtual network. What you'll need to do is, as I said, with using Active Directory, you will need your own DNS, right? Because the Azure DNS will not support dynamic registrations. It won't support all the SRV records, so you're going to have your own AD DNS on there. The other thing we can do is we can take VNet and we can connect it through a gateway down to our corporate network. So when it comes to setting it up, when we're doing VNet, number one, we specify the affinity group, we specify the address space, we specify subnets, and DNS server addresses. Now, when we put a virtual machine onto subnet 1, for instance, all right, it will be allocated an IP address. We don't actually know which IP address it will be allocated, but it'll be somewhere. So subnet 1 is the 10.30.1 network. It will be allocated an IP address on that network. All right? We have no influence over that. If I told you it would be the first one you put up there would be .4 and the next one .5, that's today. Tomorrow, it might be something different. Basically, you don't know. All right? When you specify the DNS server addresses, you don't know where your DNS servers are until you've deployed them. Right? And there was a real chicken and egg problem up until about 3 weeks ago. Right? And that was, once you'd specified the network and you deployed a VM onto it, you could no longer change the DNS server address. Now you can. That problem's been solved. So we specify DNS server addresses. I'll show you how we do that in a minute. The next thing is, if you want a gateway, what you'll have to do is specify a subnet for the gateway. You will need to specify the IP address of your VPN device, right? And you will need to specify the address ranges for your on-premise, right? Because if you think about it, we need to know what to route down to on-premises. So we need to specify the subnet ranges that are on-premise. All right? So, and then the public IP. So the gateway up in Azure will get a public IP. You will have a public IP for your gateway, or for your VPN gateway. And with the gateway enabled, we can then start communicating with on-premises. So what I'm going to do is actually just show you the process of creating a virtual network. And I'm going to do that going down to networks down here. Yep, I haven't switched over yet. Well done for spotting that. So we're coming down here to networks. Now, what I'll do is I'll go create a new one to begin with, but I'm not going to go through the whole process because it sort of will sit there for a while doing it. So we custom create a network. And when we custom create a network, we give it a name. So we'll call this, TechEd 2013. Good name. And we choose an affinity group. If one of those affinity groups doesn't work for you, you create a new affinity group. So when you create an affinity group, you're basically associating that affinity group with a region. All right? And by having that affinity group, you attach the storage to the same affinity group, and you'll make sure that everything is kept in the same place. So I'm going to just use affinity group which I've got, which is Azure Services. So next on there, and then it's asking for your DNS servers. Well, if it's a cloud only, you don't know your DNS servers addresses. So we'll have to leave that until we've deployed our DNS servers. We can configure a point to, well, let's start actually with this one, because that one's under preview. We'll configure we're going to go from our virtual network in the Azure cloud down to on-premises. And to do that, what we need to do is choose a local network. And if necessary, you can specify a local network, and it would ask you for the IP address, the public IP address of your VPN gateway, the subnets associated with that local network, and so on. The other alternative is, which is new, is the ability to actually do a point to site or a site to point, so we can actually now choose individual clients that we're going to allow connectivity to. So these are on-prem thing, or you can do both. So we got that option. But let's, for the moment, just stick with, let's say we're just creating a cloud-only network. If we go on from there, then it gives us an address range. We can choose out of the private address ranges, and I'm just going to go, let's make this guy the 10.10 network. All right, and so we need a /16 on there. And I've been experiencing this problem with the, in fact, let's not do that. Well, now I can change it. All right, seems to be a little UI hitch. Some of the things they've been doing actually not through the UI, but doing it in PowerShell. I'm going to stick with 10.10 with the /8. And then we can, having added an address space, what we can do is we can choose the different address spaces and add subnets to it. So let's just take that out of the way, and let's take subnet 1. You give it a name. What should we call it? It's my AD subnet, and it's 10.10.1, and we'll make that now a /16. Add subnet, and so on. So you create subnets, you click OK here, and that has created your virtual network. So here, I've actually got a virtual network that I created earlier, which actually has a gateway. The other end of the gateway is currently not running. So if we look at configuring this, it has an in-cloud DNS, it has an on-prem DNS, and we've got a definition of the local network as well, and then we've got various subnets on here. So an Active Directory subnet, a front-end subnet, a back-end subnet, and one on which the gateway sits. If we go up here and look at the dashboard on this, what you'll see is it's actually connected down to, well, it's attempting to connect down to the gateway, which is on premises, which is currently disabled. But what you can do is you can download the VPN configuration for the other end. And at the moment, the vendors are Cisco, Juniper, and if we choose Microsoft Corporation, what we can have is at the other end, we can have RAS, it only does RAS, for Windows Server 2012. So if you haven't got a Cisco or Juniper device, you could actually choose to use Windows Server 2012 at the other end for your connection. And if we actually look at that configuration script, so let's just download that. It's got a little PowerShell script which you run, and there it is. Let's open it up. And it gives you the PowerShell to actually configure your 2012 server, so the other end of the VPN. So if you're not particularly familiar with setting up VPNs, it's really useful. And actually, if you read through these scripts, and you can actually configure TMG and all sorts of other. So these are the ones, there are scripts ready to go with, the Cisco devices, some Juniper devices. But by just looking at the scripts, you can figure out what you need to do for different VPN devices as well. Because I know quite a number of organizations who've used different devices. They just use the scripts to work out what needed to be done. Okay, so that's the VPN, and I've also got a web farm, and on the web farm, I've actually got a number of servers actually deployed, and if we look at the configuration of my web farm network, I've got one DNS server, which is currently pointing at 10.30.3.4, and I've got a front end, a back end, and an AD network. Okay, so that's the gateway and the virtual network. Now, when it comes to deploying VMs, how do we actually get them up into the Azure cloud? So what we can do is we can literally upload our Hyper-V images into blob storage, and having put them in blob storage, we can attach them to a virtual machine. So we've now got VM run 1 running with an OS we uploaded and with a data disk that we uploaded. All right? The other thing is you could be running up in the cloud and you say, actually, wouldn't it be nice to do some work and do some sort of lab work on that particular image, and we want to do it on premises? Well, you can download your VHD as well. So it is a two-directional thing. And there's lots of different tools that you can use for uploading and downloading. I just showed you one which was Azure Explorer, so you can upload and download with that. There's also command line to be able to upload and download. It must be a fixed disk, though, so it can't be a dynamic disk. And then you can create from gallery. So there are images that you can use yourself. Plus, what you can do is you could use an image, right? You can build your VM. Having built your VM, you can add things to it, not the Active Directory, but other things, all right? And then you could, for instance, add the roles for Active Directory, but not actually promote it. And having done that, you could save that as a gallery image. Right? And the way you do it is you basically sysprep it, and then it goes in as a gallery image, and then you can use that for creating further virtual machines. You can actually put VHD disks into the gallery as well. So if you've got a VHD disk which has been configured with the operating system, you can add that to the gallery and just build your VMs from that. So there's a couple of VMs running. Remember, attached to VHDs in your blob storage. So you need that storage account first of all. Now, this is an interesting one, and this is slightly, if we're used to on-prem machines, right? We deploy a machine, we deploy a machine, we deploy a machine, and so on. Azure has this concept of a cloud service, right? And when we deploy a virtual machine, it goes into a cloud service. And if we deploy another virtual machine and another virtual machine and another virtual machine into the same cloud service, they all would have interconnectivity without the need of a virtual network. So everything within the cloud service can communicate with everyone else. And in a cloud service, you also have DNS resolution because it will use the Azure DNS, right? Well, we're not interested in that. What we want is our ADs on a virtual network, all right? But what I have to do is when I'm deploying my DCs, I must put them in the same cloud service if I want them in the same availability set. So if I'm going to deploy 3 DCs up there, what I do is I deploy them into the same cloud service, which will allow me to have an availability set that they're all joined to, which means those DCs will be across different fault and update domains. Right? And that's very important. And it's not at all obvious when you come across this for the first time. You create a DC and you say, oh, yes, I'll have an availability set. Then you create another machine, and that availability set's not available. And you go, hang on, what's going on here? And I'll show you that in the UI in a second. The other thing is your cloud service will have a URL associated with it. Okay? So in this particular case, it's xts-dcs.cloudapps.net. And that is a public, fully qualified domain name that resolves to a public virtual IP address. While that cloud service is up and running, that VIP will never change. Right? So all the machines that are deployed into that will have a mapping for endpoint mapping. So we've got a single IP, but if we want to RDP in to that public IP address, then what will happen is we have to RDP in with different port numbers, right? And that will get mapped across. So that is very unclear on that, but let me just sort of read this out because I'm not sure it's that clear at the back. So for remote desktop, TCP, and what it's 57974 is the public port, which of course goes to 3389, which is our private port. And the idea of in a cloud service, you could deploy web servers into a cloud service, and you could do load balancing as well. So we could load balance port 80, we could load balance 443, etc. But just remember, you need to deploy the DCs into the same cloud service to get the use of the availability set. IP address allocation, as I say, you don't know what it's going to be. It's going to be on your subnet. You know the first one you deploy will be .4, next one .5, next one .6, but don't rely on that. All right? So you've no idea what it's going to be, and they're dynamically allocated at deployment time. This is the internal address. It will not change, right, through service healing, and it will not change through host updates. Right? If you shut down your virtual machine, as in shut down, save money by not being charged, and then restart it, it will have a new IP address. All right? So you'll lose the fixed IP address, well, the IP addresses that last for the lifetime of the virtual machine. So how do we specify our DNS servers? The way that we specify our DNS servers is we need to do it as part of the network definition, all right? And it's a bit like, you know, with DHCP, you specify the address range and your DNS servers. So when we create a DNS server as part of the definition, it's a bit like doing it in DHCP, all right? But the problem is we don't know the address of the DHCP, of the DNS server until it's been deployed. So what we have to do is we have to deploy our first one, and if you're deploying cloud only, deploy the first domain controller on VNet, read its IP address, right, and then update the VNet configuration with the DNS server definition to set the IP address appropriately. Right? Previously, you couldn't do that, but luckily they fixed it. In fact, interestingly enough, last Friday, it was sort of fixed, but broken in the UI. So you could do it through the network configuration file. And when I just checked it, I think I checked it yesterday, it was now working in the UI. Right? So this is it's an evolving platform. If you're deploying hybrid, then if it's hybrid, you'll probably want to be able to, well, especially if it's hybrid and you're promoting a domain controller up here, it will need to attach to a DNS server down here. And then, so you can specify, when you create the VNet definition, you can specify your on-premise DNS address. And then once you know where this is deployed, you can specify your in-cloud DNS address. Options for deploying AD itself. Well, if it's just for your cloud, so it's in cloud only, that's easy. It's a DC promo. All right. If you're working with on premises, then you could do an install from media. You could install a DC on a virtual machine on premises, and then upload the VHDs. That would be another alternative. It depends if you can actually, if you do a DC Prom up here, everything's got to go across the VPN. So if it's a small Active Directory, fine, but if you've got a great big, huge database, you will need to look at install from media or some other method. Okay, this is VM stop-start and DNS. As I say, and this is stop-start, and I should have qualified that, stop-start, save yourself money version. This is not stop. This, very importantly, this is not stopping a virtual machine. This is stopping it and having it out of the equation so that you're not being charged for it. So if you go into your virtual machine and do shutdown, it's sitting there not running. That's a not running virtual machine rather than a completely stopped and out of the equation virtual machine. If you do that, you lose your VIP and you also lose the internal IP addresses. So if you've got a deployment environment you bring up, all right, you will need to check out what your DNS server addresses are and then put them back into VNet appropriately. So you'll need to make that change. Okay, so what I want to do is actually go through the process of just the various bits and pieces to get one of these guys up and running. So we've got our virtual network. And so what I can do here is that's the virtual network we've got, and I'm using the web farm network. So what I can do is I've actually already deployed a number of virtual machines. Sorry, yeah, thank you. I've already deployed a number of virtual machines. I've got 2 DCs, and I've got 2 jump servers, all right? And we'll see why in a second. So this DC, and if we look at the DC in more detail, and we look at the dashboard, what we can see over here is the actual cloud service is xtswebfarm-ad.cloudapp.net. And if we look at the endpoints on that, what we can see is that PowerShell, this is PowerShell remoting. The public port is 63562, remote desktop public port 64615, and to 3389. This is in this cloud here, cloud service. If we look at DC2, it's also in that cloud service, all right? So if we look at the endpoints here, let's just take the remote desktop, for instance. It's the public port for that is 58072, and internal is 3389. So your RDPing is all to the same IP address, however, the port numbers will be different, and that differentiates between them. Now, what you may say, look, actually, I don't want anyone coming over the internet to a public IP getting at my DCs. In which case, what you can do is you can actually remove these endpoints and do everything internally. And this is why I've got this concept of a jump server, so that you can actually come into the jump server and then go and do all of the work on the domain controllers. So but what I want to do first is deploy another VM. And I'm not going to go through the complete process. So new VM, and we go virtual machine from gallery. And we've got the ability of choosing a flavor of virtual machine. Let's just go for the Server 2012 data center. And next on there, and we need to go a virtual machine name. Well, DC3 sounds like a good idea, seeing as we've got one. And then you think, oh, I know, yeah, we need a username. So you use admin. And it says the username is not allowed. And you think, oh, OK. And you go administrator, and you get the same thing. And you say, oh, I know, I'm old school. I use root, and it doesn't allow it. What it does is it tries to avoid you using the most popular names used for administrators. So I'm in here. I'm sure there'll be a new AD admin. It allows that, so I'm sure lots of people use that. Password. Sorry, I mistyped that. And on from there. And now, we need a DNS name if we're deploying a new cloud app. So I'm just going to use TechEd in there. Let's see if that's allowed. That's not allowed. 2013. That's not allowed because it's already in use. I thought it probably would be. So how about that? That's OK. So I can use that as and this will be my fully qualified domain name, allowing me to get to that cloud app. And I choose a storage account. So I'm going to go for XTS101. And I'm choosing to put it on the web farm network. And I can choose which network I put it on. So I'm going to put it on the AD network. Next on there, availability set. There aren't any. That's weird, because if I go back to my, actually, I'm going to lose this screen if I go back. If I go back to my 2 DCs, they're in an availability set. And you sort of scratch your head for a long time. You create an availability set the first time you do this. And the thing is, what you need to do is not deploy it into a new cloud service, but connect to an existing virtual machine. And I'm going to connect it to inside the cloud service XTS Web Farm AD. And you just choose one of the machines from in there. It doesn't matter which one, right? And now what it does is it automatically, it's chosen Web Farm. You can't put it on a different network. You could put it on a different subnet, but I'm going to choose that. And now what you'll find is, yes, you can choose the Web Farm AD availability set. So this is so important to choose your availability set to make sure your DCs are across different fault and update domains. All right, so do remember that's the way that has to be done. Okay, having deployed the thing, I can actually, if this is DC2, if I go to the dashboard, I can go connect and open the RDP. And so we specify, so this is connecting me up to DC2. And once we're up there, I haven't currently got DC2. Put DC1 as a DNS server, but I haven't done DC2. So I just want to show you how we do that. And this connection seems to be horrendously slow, but we'll get there in a second, I hope. Come on. Is anyone good at singing? All right, I'm not going to, it's estimating the connection quality. I don't think it needs to estimate it. It's appalling. Let's leave that, because I know all I was going to do is, once I was in there, I was going to do an IP config. And what I want to do is actually show you what I know what its IP address is. So once you know its IP, what we do is we pop down to, the network configuration, and we come in to the DNS servers. Those are the DNS servers at the moment. What I can do is I can come in and I can register a DNS server, and we'll actually call this DNS server, what's it called? Web Farm DNS2. And you can then put in the address of this thing, which I should know. And no, actually, oh, yes, I do. It's 10.30.1 or 1.5. And having got that, what we can do is, once that's created the DNS server, we can actually add it into the network definition. And having added it into the network definition, what you'll have to do is, for any servers to use that new DNS server, you'll need to reboot them. But that's so what you do is you set up your DNS servers. So you put in your first DC, your second DC, pick your DNS servers, put them in the network definition, and then you start bringing in your other VMs, and they will automatically get that particular definition. Okay, and last but not least, what I'm going to try and do is actually attempt to connect to my, I'm going to attempt to connect to my jump server. And actually, that's very interesting. I've actually got two jump servers, and the reason being that we might not have been getting at that particular server is it was going through an update, because it was in the, so let's see if we can connect, there we are. Let's see if we can, no, actually, that's not true, because we'd actually logged in, hadn't we? Oh, look, that's looking more encouraging. Or did we get there before? Okay, I'm going to just leave that. Oh, yes, we're getting there. Okay, and this is just really what I wanted to show you is we can actually, if we actually use Server 2012, we can actually do all of our work from one server. So this is my jump server. If I want to go to DC1, I can do Active Directory administration against DC1. I've got all my event logs from DC1, all my event logs from DC2, and also services that are running, so I can stop and start services here, so that I can start this service. And if I want to, I can go across and do my, let's just try going across here. We can go into remote desktop connection, and I go straight now across to that particular server. And that will take me across in the Azure platform across to that server. But so that is one of the reasons that we might deploy into the Azure, into Windows Azure Cloud. We might have an AD so that we can do management from a single source up there. Oh, and if you need help, there's a shameless plug for with my email address. So by all means, contact me if you've got any questions or queries. And it brings us right to the end. And hopefully, that's given you a flavor of how to run your AD in Azure. The other thing I wanted to absolutely get the message about is if you're doing it for authentication, very seriously think about using Federation and the Windows Azure Active Directory itself. If you've got any questions, by all means come down, but we're right at spot on time, and I'll leave you to the rest of your day. Thank you.